Okay, so in this module, we will see the architecture or say schematic diagram of a modern memory that is used in the computer. So in microelectronics, we have the memory chip and an architecture or in the form of a schematic is shown right over here. So basically, memory has address lines, n number of address lines, and those address lines tells us the location inside the memory where the data is stored. So this is the inside part of the memory where the data is stored. And it is shown in the form of a number of rows and number of columns, and which row is to be selected in order for the data to access. We can read that data from the memory or we can write that data inside the memory. So how to assess that data which is inside the memory depends on which row gets selected. And which row gets selected depends on the address lines that are used. So in this one, you can say in between the inside the memory, you also have one digital logic block called as address decoder. So when you have n number of address lines, 2 to the power n are your number of outputs of that decoder. So for example, if you have three address lines, 1, 2, and 3, so 2 to the power 3 would be 8 output lines of that decoder. And that address decoder is called as 3 to the 3 is to 8 address decoder for the memory mapping. So we'll see in terms of this table how that memory mapping is done right here. So you have these address lines, three address lines. So let's name them A2, A1, A0, starting from the MSB, uh, most significant bit, and A0 is the least significant bit. And you got this address of the memory because there are three address lines, so there are three bits, A2, A1, and A0. So start from 000, 001, this is a binary system, up to 111. So total 8 address a memory location for the three address lines. So there are 8 memory locations, and those 8 memory locations, each of those memory locations stores data called as word, and that word indicates how many bits inside that word in that location. So decimal address right over here is 0 for the binary representation of 000. Then for 001 you have 1, for 010 you have 2, up to 111 the decimal number is 7. So you got the decimal address of the memory also in the decimal system. Then the decoder output lines is 0, 1, 2, 3, up to 7. So total 8 output lines, as you can see from right here. And depends on what is the what are the values are placed at A2, A1, and A0. Suppose 010, that particular location is selected because that particular output line of the decoder gets activated, and remaining output lines remain inactivated. Okay, so let's say you select number 2, for that the address is 001. So you have second, the decimal address here is 1, and the location M1 gets selected. So now when you have a particular row selected, in that particular row, These are called as control signals, read or write, chip, select. So there are, let's say, total three signals. So this could be a combined control signal also, read or write, depends on whether you have 0 or 1. You should put a bar over one of the control here. So first of all, when you have this chip signal, select signal, this is an external signal coming for the memory inside the memory. So when you place logic 0 or 1, depending on your memory logic, your chip gets activated. So if this signal is not activated, your chip is disabled. When this signal is activated, your chip is enabled. And once you enable your chip, you have to provide another control signals that shows or that tells whether you are reading the data or writing the data, depending on logic 0 or logic 1 you put here. Once you decide whether you want to read the data or write data, you have these data bus. You have this data bus. You see the bidirectional arrow. Bidirectional arrow indicates you can either read the data from the memory or write the data inside the memory. So you have this data bus, and obviously this is at a time you can read uh, an 8-bit data or uh, 4-bit data or 16-bit data or 32-bit data, depends on the data lines, the data bus. So if it is a 8-bit data bus, n number of data bus, so it means you can read or write 8 bits at a time. So, okay, so this is how the typical memory, the modern memory architecture looks like. Hope you found this module useful. If you did so, share it with others for wider reach, and stay tuned for more engaging content like this. Till then, wish you happy learning. So before leaving, an exercise for you or a quiz for you. Let's say I have two address lines. Write in the comment section how many output lines of this decoder will have. Accordingly, create a table and accordingly tell which row, if you want to select a particular row, what combination of address will do that. Okay, so binary combination, you have to tell that. So two address lines. Let's say after that you have four address lines, and accordingly five address lines, and so on and so forth. Okay, so see you for the next module.